Hi everyone, welcome to video number 5 of physics mechanics and the third and final part on forces. This video will cover universal gravitation. You will learn how to determine the force of gravity between any two objects and how to determine the acceleration caused by gravity. I'll start off by showing you how to find the formula for the force of gravity. We're going to be using a PhET simulation, which I'll link down below in the description if you want to explore it by yourself. So we'll start off with these objects, the max distance of 10 kilometers apart. And you may notice that the force of gravity on each mass is the same. This is because of Newton's third law of motion. What would happen if we halve the distance to 5? Right now, the force is 5.3 newtons. So if we have the distance down to 5, then it turns to 21.4 newtons. So it was multiplied by approximately 4. And since these numbers aren't exact, they're all rounded to 1 decimal places, we're just going to say that the force was multiplied by exactly 4. All right, so now what if we have the distance again to 2.5? Right now the force is 21.4 newtons, and it turns to 85.4. So it was multiplied by 4 again. What would happen if we triple the distance to 7.5? Right now the force is 85.4, and it turns into 9.5. So it was divided by 9. And you might start noticing a pattern right here. Whenever you multiply the distance by a number, the force is multiplied by 1 over that number squared. And that means that the force of gravity is proportional to 1 over distance squared. So now we have the relation between gravity and distance. What about mass? So right now, the force is 9.5 newtons, and mass 1 is 2 billion kilograms. So what would happen if we halve the mass? The force turns to 4.7. So it was divided by 2. Now what would happen if we triple mass 1? The force turns to 14.2. So it tripled. And let's double it again to 6. So the force doubled to 28.5. You might notice a pattern. Whenever mass 1 is multiplied by a number, the force of gravity is multiplied by that number. That means that the force of gravity is proportional to mass 1. And the same can be said for mass 2. If we have mass 2, then the force is halved. If we have it again, then it's again halved. If we triple it, then the force is tripled. All right, so now we have the information that we need to find the formula for the force of gravity. We have that the force is proportional to 1 over distance squared, the force is proportional to mass 1, and the force is proportional to mass 2. Putting these all together, we get that the force is proportional to mass 1, mass 2 over distance squared. And you can also write that as force is equal to a constant times mass 1, mass 2 over distance squared. This constant is capital G, which is the universal gravitational constant. And isolating G, you get that G is equal to Ft squared over m1, m2. So going back to the simulation, we can determine what the value of G is. You can set the distance and masses to any values you want, but we're just going to use the default values. So let's calculate G. G is equal to F, which is 33.4, times D squared. D is 4 kilometers, but we only really use meters in physics, so that is 4,000 meters squared. So now we divide by mass 1, and we're just going to ignore the billion for now. So divide by 2, and then divide by mass 2. Once again, we're ignoring the billion. All right, and since we ignored the billions, we now have to divide by 10 to the power of 18. So this is our value for G. And let's see how many digits we need to move the decimal over to express this in scientific notation. So 2, 4, 6, 8, 10, 11. So our value of G is 6.68 times 10 to the power of negative 11. The actual value of G is a little bit different at approximately 6.674 times 10 to the negative 11th. The reason why our value of G was a little bit off is because the values were rounded to one decimal place. So from now on, we're going to be using 6.674 times 10 to the negative 11th for all problems involving capital G. And now the units for capital G, well, you can get that from the formula for it. So capital G is equal to F, which is newtons, times D squared, which is meter squared, over the product of the two masses, which is kg squared. So the units are nm squared over kg squared. Now we can determine the acceleration due to gravity. We need to use the formula for the force of gravity and F equals ma. And in this case, we're just going to be using object 1 for F equals ma. So plugging in what F is equal to into the first equation, we get m1 a1 is equal to g m1 m2 over d squared. Now dividing both sides by m1, we get that a1 is equal to g m2 over d squared. So what this tells us is the acceleration of an object due to gravity is equal to capital G times the mass of the other object over d squared. So using this, we can determine the acceleration due to gravity on Earth. So suppose object 1 is our object and object 2 is Earth. So we plug in all the values. So we know that capital G is 6.674 times 10 to the negative 11th. The mass of Earth is approximately 5.972 times 10 to the 24th and divided by d squared. So we can just plug in the radius of Earth for d. Yes, the distance does depend on whether or not the object is elevated. However, it doesn't really matter because usually the elevation is only about like 10 meters or something, and that is hardly anything compared to the radius of Earth. So that's why we can just plug in the radius of Earth for d. So now solving for a1, you get that a1 is equal to 9.8 meters per second squared. This is why the acceleration due to gravity on Earth is 9.8 meters per second squared. So now here's a practice problem. If you want to give it a try, pause the video here. The solution will come in 3, 2, 1. So we just used the formula for the force of gravity. F is equal to G m1 m2 over d squared, and plugging in all the values. And then we can isolate d squared by multiplying both sides by d squared and dividing both sides by 100. And finally, taking the square root of both sides, we get that d is equal to 812.58 meters. Here's another practice problem. If you want to give it a try, pause here. The solution will come in 3, 2, 1. So we use the formula for acceleration due to gravity. A1 is equal to G m2 over d squared. And we plug in all the values to get that A1 is 85.64 meters per second squared. Now be careful because the problem gave you what M1 is equal to. However, you don't actually need to use it in the formula. So be careful on these types of problems because they might try to give you the mass of both of the objects, and you need to be careful to make sure that you're using the mass of the correct object to plug in into the formula. So this is a summary. There's not a lot for you to memorize. You just need to memorize the two formulas and the value of G, and that's pretty much it. So I hope this video was really helpful. Now that we've finished the part on forces, in subsequent videos, we will see how forces can cause many different types of movement. So just make sure to have the 4 important forces down. gravity, friction, tension, and normal force. And I'll see you in video number 6.